Open in progress. Well, hello and good afternoon again from our studios here in the Afrinic office here in Mauritius. I already see some people saying hello in the chat section. If you can hear me, just say 1 in the chat, let me know. Just type 1 in the chat. All right, that's awesome. Apologies for the wait. We had some technical challenges in the background. We had to sort out quickly. All right. So as usual, I always invite you over. I can see hello from different countries already, but I always invite you over to menti.com. You type in a code. In this time for this session, it's 48472147. Or let's get to the all right, so let's go to the Menti itself. All right. Let's see. Okay. All right, so let's see how many of us are here. 60. So half of us have voted. So 30 have voted. So like I said, go to menti.com. Please go to menti.com. Type in 48472147. Or you can use your phone to scan the QR code there. So a little bit of the same pattern. Nigeria, South Africa, Malawi, South Sudan, Zimbabwe, you all stand out. And somebody says from hello. All right. All right.
Oh, there is someone from Bafanji.
Where's that? In Cameroon?
Yeah.
Okay.
That's my village in Cameroon.
I see. All right, so you see, awesome. Thank you very much for that. So we have 41 votes. With South Africa, Nigeria, Malawi do stand out. But thank you all for joining us from different parts of the continent and beyond. So as usual, again, very quickly this time around for this last live session, the simple house rules, looking at the chat section where I asked you to say hello if you could hear me just now. So the same thing here, if you have issues, with the stream, technical issues, audio or video, please post them in the chat section. And of course, also, if I need to post a link or something, I have to put it in the chat section also. So use the chat icon on the bottom of your Zoom client to do that. And then again, as the presenter is presenting, if you have questions about the topic, please use the Q&A feature by using the Q&A icon below on your Zoom client. And then finally, again, if you want to talk, I don't like talking all the time. I want to hear your voice also. Please, you can raise your hand and one of the co-hosts or myself will allow you to speak. And then we can go on with the presentation. So you can ask your question with your voice instead of typing it in the Q&A section. So, ladies and gentlemen, welcome to the 5th, correct, and last live session for this 0 to certified IPv6 engineer in 21 days. It's been a bit of a long journey, although, like I said earlier, on Wednesday, we expect you to complete all the e-courses by 25th of October. That's Friday, 25th October. All right. And in that, when you do that, that's when, for example, all the top 5 learners who have been participating in the quizzes and have been the top 5, that's when you get to benefit from that 100% discount that has been given to you right now. But you can't take advantage of that unless you finish all the 7 e-courses, starting from IPv6 foundations down to mastering IPv6 transition mechanisms, which we are going to cover today briefly. So, and of course, you have to pass the quizzes. And I keep mentioning, just like in email communication you got yesterday morning, I think, the pass mark for those quizzes is at 80%. And you can take it as much as possible until you pass it. It's not that you have one shot at it. You have many shots. All right? So, but you need to complete all 7 courses, pass the final quizzes or exams before 25th October. So today, as you can see, since I saw a lot of comments on Wednesday about Mr. Onway's presentation style, decided to invite him over again today. Like I said, he's our veteran trainer here in the capacity building department. And we invited him over today again to help us out or instruct us in the concepts behind transition mechanisms from IPv4 to IPv6. All right, so welcome again to the studio, Stephen.
Thank you, Mr. Ola. Thank you very much. So, yeah, I guess it's over to me now.
1 second. Let me
Okay.
let me give them the agenda. So the agenda today very short. We just do IPv6 transition mechanisms, and after that, you can ask questions while it's going on, and of course, then after the end of the presentation, you're going to have questions also, and then we're going to invite you to take a survey again, as we always do, and then we will spin the wheel for the 2 lucky winners. Now, of course, there will be quizzes, and we're going to select the top 5 again. And as for clarity again, or to clarify some questions from people asked by email recently, you cannot be top 5. If you're top 5 more than once, which is we've seen the case here, you can only get 1 a discount code, all right? So if you're top 5 on the first live session and you're top 5 again in the second live session, we'll have to remove you from that and give room for people who are below you to get that, okay? So, but please, if you've not been in the top 5 since the first 4 live sessions, please try to be in the top 5 today, all right? So we can have new, fresh people, learners, all right? So over to you, Stephen.
Thank you, Ola. Thank you very much. Today is Friday. And, yeah, I guess and I hope we are going to have fun today again. And yeah. So, in the chat again, can you hear me? Can you hear me in the chat, please? All right. Okay. Good. Merci. Asante Sana from those in Kenya. I don't know how you say that in Kosa. Oh, yeah. Yeah, okay. Yeah, I see some French-speaking people in the room. Oui, bienvenue, welcome. Yeah, so I will start here by asking you to rate yourself, right? Yeah, Ola, that's a question for you.
You did actually. There's a link for you to download it. I don't know why Emmanuel Ado did not get that because I saw a response from other folks, but let us go on. We'll address that at the end.
All right. So today we are going to talk about transition techniques. Okay, we are going to talk about the transition techniques or transition mechanisms. And before we start, I would like you to type in the chat, rate yourself on a scale of 1 to 10. How comfortable are you with transition techniques? On a scale of 1 to 10, how comfortable? Oh, okay. Uh, ah, all right, interesting. This is interesting, okay? I can see people, yeah, this is good. Okay, so the session today is not, we are not going to go deep as, but at least we are going to describe what these transition techniques are. And trust me, you all know everything about these techniques. And yeah, so there is only one person with a rate of 8. That's above 7. Everyone is either very, very uncomfortable with it or average. So my next question for you is, on a scale of 0 to 10, rate yourself on how good you are with techniques like VPNs, IPsec, yeah, VPNs. How good are you with VPNs? There you go. Interesting. All right. Okay. Good. So on another question, the last before we start, on a scale of 0 to 10, how good are you with IP encapsulation? Just the understanding how it works and things like that. How good are you? Right. Okay, so should I share my screen or I use this one? All right. Can you all see my screen? Hola, confirm.
Yes, we can confirm.
All right, so thank you very much for your rating. In this session, we will have a quick overview of the various techniques, transition techniques. We will try to understand why we need these techniques and how they work and various common techniques that we have for IPv6 transitioning. So that said, my first question for you is, Why do we need transition techniques? To your knowledge, why do we need transition techniques? Why do we need transition techniques? Okay, I see, for seamless flow to IPv6, because we cannot just abandon IPv4 and jump to IPv6. Yeah, all of these are very valid responses. So, just to summarize all what you said there, if you look at this slide, right? At the intro section, I guess Olatunde and Bashi explained to you that IPv4 and IPv6 are incompatible. All right? IPv4 and IPv6 are incompatible, right, Ola? They are incompatible because the packet structure of IPv4 and the packet structure of IPv6 are different. So these two protocols cannot talk to each other. It's like me landing in China. What is your favorite city in China? Xinjiang. Okay, it's like me landing in Xinjiang. I don't know how to speak Mandarin, so I'm going to be confused. I'll be talking either English or French or some Creole, or my mother tongue back home, which is called Chufie. I'll be talking one of these languages, and they will not be able to understand me. So IPv4 is like the Mandarin, and then IPv6 is my mother tongue that I speak. And we need to understand each other. As you rightfully say, basically, the two protocols cannot speak together. They cannot communicate. So if you have a device that's IPv4 only, it cannot communicate to a device that is IPv6. And right now, we haven't migrated the internet totally. Okay? We haven't migrated the internet totally. So part of the internet sits on IPv4 while there are new servers, new resources coming online and having IPv6. And we also have like a mix where you have devices that are having both IPv4 and IPv6. So someone said in the chat that for business continuity, we cannot just say, oh, I'll move my network to IPv6. If all of us, right, in the world, we could agree that, hey, let's move the internet to IPv6, good, we could abandon IPv4. All right? But then there are some legacy softwares, some legacy equipments, which we cannot move directly to IPv6. Okay? Some vendors, some equipment that, let's say, had reached the end of life, and the vendor is not more like producing those devices. What are you going to do with this device? It is not supporting IPv6. So how are you going to do about it? In some, maybe ministry somewhere around Africa, there is a particular server in a server room, in a server farm, that cannot support IPv6. How are we going to do about this? So, just as me landing in China and not being able to speak Mandarin, we need some way to talk to each other. All right? Me, I will speak my truth here, and the other person there needs to understand what I'm saying. So, we basically need a transition technique. For the period where I will be in China, for me to learn Chinese, or for that person to learn my language, there is a transition period. there is a transition period. And during this transition period, we need something that we will use for soft landing. All right, this is why we need transition mechanism. Now, let's start this. Olatunde is going to start.
All right. So as you can see on your screen, so you go to menti.com or okay. All right, let me start. There we go. Oops, sorry. So see what you have on your screen. Can you see it? Just scan the QR code and type in 61152990. The technical gremlins came on here again. Sorry about that. You can't open Menti on two computers at the same time.
Okay, this is interesting. So we have the results, Olatunde.
Yes, we have the results, and they're kind of very self-explanatory. So which of these is a scenario? That should be this. I'm sorry, it should be plural. Sorry, it's a scenario where a transition technique is required. Now, in a dual stack network, that means you have both IPv4 and IPv6. So, like, Stephen here now speaks English and French, so he doesn't need an external translator. If someone is speaking English to him or someone is speaking French to him, he can understand. All right. So IPv6 only network is definitely correct because if he speaks only French, for example, now he can understand English. He needs some translation or translation mechanism in that part also. So in the tunneled network, I remember Stephen asking you today about your skills with VPNs, IPsec, and all that stuff. In the tunnel, well, you will see them later on. One of the ways we do transition techniques or implement IPv6 transition mechanisms is by tunneling. So you don't require, in the tunnel network, you don't require that. All right. So if it's an IPv4 only or IPv6 only network, then you need some sort of transition technique. So that's why that one is correct. So let's look at the leaderboard. Sorry about that. There was we had the Menti open on two computers at the same time, and that's not allowed. So let's see.
Kathy.
Okay, so I forgot to mention, but that's fine. So what's going to happen today? Because you're supposed to enter the competition with your real names. So I don't know who Kathy is, but at the end of today, I'm going to send what's going to happen is I'm going to send the email. You're going to get the email about the top 5 with this your, I don't know what you call them now, ID. Okay, what they call them on PlayStation Network, I remember. Anyway, so this is your gaming ID right now, this quiz competition ID. So you have to please take a screenshot of that, like Kathy, for example, now with the umbrella icon, so you can prove it is you, all right? When I published that, okay, Kathy was first at the end of today's session, you prove it is you with your real name. Because actually you're supposed to enter this quiz with your real name, your first name and last name. So for now, Kathy is first. Right.
And to know the first, we will be running this quiz throughout the session. Is at the end that we'll know the top 5. Okay. All right. So let's look at what our networks look like. Okay. So basically, this is how our network is. We have the core. All right. We have the core of our network. where we have all those huge routers that carry all the traffic and the routing and everything. And then at the edge is how we connect to the external world, the internet, and maybe our upstream providers, other customers, other peers, and so on. And then here we have our access network. And in our access network, we now, like for the case of an ISP, you maybe have a network to connect enterprises, that's the corporate customers. You have a network to connect the home users with things like FTTH and ADSL and so on. And then you have your mobile network, um, and then you have campuses. We can look at campuses here, like various sites of your of your enterprise. Maybe as an upstream provider, you are present in maybe 3, 4, 5 cities, and then you have like many sites. And then still in this your access network, you might have a particular segment that is where your staff are sitting to do their job on a daily basis. So when you have a network like this one, all right, in terms of IPv6 and IPv4, what are the common scenarios? What are the...
1 second. Is the audio bad? Because I don't understand. Someone says they can't hear anything.
Can you hear me?
I have audio. Okay. So you can hear loud and clear right now. So Delmiro, who raised his hand, is that question regarding the technical challenges, or you have a question for Stephen? So Delmiro, yes, you can. You have a question? You can talk. Hello? All right. Go on.
Ask to unmute. All right, Demiro, if you have anything, just type in the chat and we will address it. Okay? All right, good. Let's move on. So this is how your network looks like. Now, one component, one part of this network would be having an issue. When I say having an issue here, it means it might be... Okay. It might be having one stack and not the other. Like when we look at the access network here, if you look at the access network, you can see that on the access network here, there is IPv4 and there is not IPv6. In this case, since we already explained that IPv6 cannot talk with IPv4 host, what is going to happen in this scenario if you want to carry IPv6 traffic on this segment of the network? What is going to happen? You see, the rest of the network, like the internet, we already know that the internet is IPv4 and IPv6, right? And if you look at, all right, we haven't discussed about maybe the enterprise, but let's just look at the access network where we have IPv4. How is someone sitting, maybe a customer of this network, or a mobile in this network, or a home user in this network, or even a staff in this organization, get access to the IPv6 content that is here in the internet? How is this going to happen? Okay, that's the first scenario. Let's look at another scenario. Here, you still have like the internet with its regular stacks, IPv4 and IPv6. But on the edge network, right, maybe you are running one of those routers which will not enable you to, one of those router or those technologies will not enable you to get access to enable IPv6 on your edge network. What is going to happen here? You won't be able, even if you are having IPv6 all over here, you won't be able to get through with IPv6 traffic. Okay, so we need to do something about this. And the next scenario is the scenario where maybe, I don't know, if is it in 2017 or so, AT&T, right, decided to push IPv6 to their mobile network. All right. So everyone got up the next day and was having IPv6. And this was a greenfield IPv6 on the mobile network. If you're in this situation where your mobiles are having IPv6, even if you're having IPv6 everywhere here, right, on the path to the internet, on the IPv6 content, how are you going, in this case, all right, no, you have IPv6. IPv6 traffic is going to be okay, all right, to the internet. But remember, on the internet here, we still have v4 content. I remember sometime back, a website like x.com did not have IPv6, all right? And there are a lot of websites like that not having IPv6. And even if we are looking in, particularly in Africa today, I guess a lot of our organizations do not have IPv6, they have only IPv4. So somebody sitting in this network, in this mobile network, how are they going to get access to that v4 content that you are serving on the internet? Something needs to happen about this. Now, the next scenario is when maybe one critical piece of software or appliance on your core network doesn't support IPv6. So you see, how do you access the internet, the IPv6 internet in this scenario? IPv4 will be cool. You can get, because you are supporting IPv4. But what will you do with the IPv6 traffic? When the IPv6 traffic gets here, it's going to be dropped. All right? So those are the scenarios. The next scenario now is when the services that you provide in your organization, because you as maybe an ISP or even a university, you have what we call the server zone. And in this server zone, you have a lot of services that you provide. Let's take the basic service that nearly all of us provide, the web. So if you're having your website here in your network, people want to access this website, and you decide, I don't know, for some reasons, to just put everything on that, on your services on IPv6. Now you have maybe your customers, and you have also people on the internet who support only IPv4. How are they going to communicate with this server? All right. So the last scenario, I'm not saying that I've been exhaustive about all these scenarios, because I guess there are other scenarios that we haven't like shown here. Another scenario is when, remember the first slide, we talked about maybe your access supporting only IPv4. What is if it's the other way around? You don't support IPv4, you support only IPv6. What is going to happen for all those people wanting to access maybe the internet on IPv4? This is not going to traverse, it's going to stop. Okay? Now, like other scenarios could be Right now, the internet, the way it is, the way we run the internet today, is a lot of NAT, right? Is a lot of NAT. And because of NAT, we have been having a lot of issues developing the internet. You know, the internet model is a model where we want end to end, right? And you can ask those who developed applications like Skype, right? Or people configuring VPNs, IPsec, and things like that. It's a problem to run these applications using in our NATed networks. So now for us to restore the end-to-end model of the internet, thanks to which we have been able to develop the internet where it is, we have been able to like leverage the power of the internet to support maybe medicine, education, and every other thing. We need to restore that end-to-end model. And the basic minimum for the end-to-end model to work is to have at least one IP address on each subscriber device, each subscriber device. It means that if you're having 10 devices at home, each of those devices should have a public IP address. That's the end-to-end model. And when we get there to where every device in your network is having a public IP address, maybe we can now do like direct calls rather than using third-party applications like Skype, WhatsApp, and things like that. The devices can connect directly without need of a third-party software. All right, I can dial up your device directly and we can speak. But right now, you see, for us to communicate, if I want to call you, I need a software like WhatsApp. All right, what if I could call you directly the way we do with our phones? All right, what if I could reach to you directly without needing a third party? So that's a scenario where we want this IPv6 to come fast so that we can now start to, boost the power of the internet. And the next one is we need for more IP addresses. It's like almost the same thing, right? We need more IP addresses. IPv4 is 4.2 billion IP addresses. The world population by 2050 is going to be 7.
Maybe 10 billion.
Maybe 10 billion, right? Maybe 10 billion. We are having only 4.2 billion IPs. And in this 4.2 billion, there are some that are reserves. There are some that are the RFC 1918. That's the private IP space. 3 large blocks of IP address wasted like that, which we can use. There are some that are used for specific applications. So in this pool, we have not up to 3.5 billion of IPs that we can use. And now, because of that poor management of IP addresses at the beginning in the 80s, where we're just sharing /8 to everyone, there are some IP space today that we call the legacy space, and it belongs to particulars. Some universities in the United States are having large IP blocks like that, while we are sitting here not having IPs anymore. So IPv6 is going to come and stop this problem. So we need to transition. IPv4 internet access from an IPv6 only network. Now, these people that we call the innovators, the early adopters, right? People want to be the first to adopt any fancy technology that's coming. There are a lot of them who are deploying IPv6 already, greenfield IPv6, and in their network, there is only IPv6, all right? So how are they going to make this IPv6 accessible to IPv4, which is still out there? And then the last scenario that I can think of here is access to private IPv4 only, right? As we speak now, more than 90% of our networks in Africa are running IPv4 only. So how do we access those IPv4 only networks. So I'm going to pause here to see if you have any question.
This one is right. So Daniel says, Daniel, next time please put it in the Q&A. I saw it in the chat there. Is it possible to configure IPv4 and IPv6 on the same DNS server simultaneously?
That is a yes, right? That's a yes. So you just need most of the servers like bind. What you have to do is, DNS, the way it operates, you have many layers, right, of configuration. First of all, your DNS server is having an IP address, all right? The way I reach to your IP, to your server is with an IP address. So if you have to enable IPv4 and IPv6 address. That's possible already on your server. Now, going to the daemon, the bind daemon, you need to configure the bind daemon to be able to listen to both IPv4 and IPv6 queries. All right. And then now, talking of maybe the host configuration, the host file, the configuration file, where you input things like A records, PTR records, and things like that. You need to also put the equivalents for IPv6. Like an A record for IPv6 is called a quat A record. All right. And yeah, so you need to enable it at many levels. Your computer needs to listen to IPv6 demands. Your bind needs to listen to IPv6 DNS queries, and then you need to be able to also serve IPv6 records. Okay. Now it depends on you what you want to achieve. What precisely you want to achieve depends. So the configuration and what you have to activate depends on your requirements.
Please use the Q&A section. Your question can get lost easily in the chat section. I can send another question there.
All right. As mobile provider, we still have many customers using legacy devices, especially in rural areas. What challenge do we expect and how to overcome it? So from your end, what you need is a technique to be able to handle those customer requests and maybe get them to IPv6. Now, basically, when they get at your level, we are going to describe some of the techniques, and maybe when we describe those techniques, you'll figure out what fits better for your scenario. All right. So let's unravel the presentation, and then we see at the end if you still have this preoccupation, then we can talk about it. Any other question?
Delmiro, is your hand still raised to ask a question or not? Because you're allowed to talk if you want to talk.
Maybe that's an old hand.
Yeah, it's still raised since then. Okay, so, all right.
Okay. The good, the bad, the ugly. So in terms of transition mechanism, there are three categories. So all these transition mechanism that you will see out there, like dual stack, things like that, they fall under three of these categories. The first category is dual stack, where we have IPv4 and IPv6 on the same equipment. All right, this is dual stack. And then you have a scenario where you can carry IP, maybe IPv4 into IPv6. This is called tunneling. Things like GRE or IP. We know the way we do VPNs in IPv4, okay? And then you have the translations. Translations is basically when you get to, take an IPv6 packet and make it into an IPv4 and vice versa. So there are And under this, each of this category, there are many subcategories. Like for this one, for the tunneling, you can tunnel IPv4 in IPv6 or the reverse, tunnel IPv6 in IPv4. Okay. For the translation, there are many technologies, and we are going to see. Okay. So let's now talk about manual tunneling. And look at this scenario, look at this graph. In this graph, you have like this ferry, okay, that's carrying the cars, okay. You know, the major here is what? You have water. We know that cars, at least at this generation, our cars cannot travel in the sea,
It's
right?
not, so it's a graphic, not a graph. Not a graph, all right?
Sorry for my broken English. The graphic.
Okay.
Sorry. All right. So you see, is it a diagram?
Yeah,
Is it
it's a graphic, it's a diagram, it's a photo, it's a
okay?
picture, all
It's
right.
a picture, a photo, an illustration. Yeah. So here our cars, right? At least at this generation, cannot travel over the sea, right?
Wait, hold on. You can't see the picture, are you sure?
Okay.
No, we cannot see. Ola,
What do you see?
nothing.
Really?
Can't see are you annotating?
Yes.
No.
Stephen is annotating. All right, let's stop and reshare. See what happens. The gremlins are here again. What about now? Let me see if I have the chat.
It should be slide 26, not 22.
So it's fine. Stop share. Is it fine now? Sorry. There seems to be a collision here. All right, yes.
So you can see slide 26, everyone, right? Okay. So here, what I was saying is in this scenario, we have the ferry, all right? As I was saying, our cars cannot travel through the sea, through water. Maybe in the future when Olatunde decides to, venture into technology, mechanical technology, then he's going to invent a car that can go through the sea and the roads. But right now, our cars can just drive through the roads. So for us to go through the water, we need a transportation mean, and the transportation mean here is the ferry, right? And the ferry can sail through the waters. Okay. Now, next slide.
Someone says the technology is here already. Yeah?
Oh, okay.
The James Bond movies.
Yeah. Yeah, I remember.
Very old movie.
Okay. So in this case, what's the tunnel? A tunnel here is you can see right here. this second scenario is we have the boat, right? It could be a catamaran or whatsoever. One of those rich guys in Nigeria or in South Africa having their own speedboat, and they keep it in their backyard. How do you get this to the ocean, to the sea? You need a transportation means, right? Because right now the speedboats cannot ride on the road. So what you do here is you have to use a transportation mechanism. In this case, we are going to use the car and how do you call this, Olatunde? This piece of device.
A trailer.
A trailer. You have to use a trailer and a car to pull this all the way to where you have to maybe go for some nice party. Next slide. Now here, what we have is the explanation of all this, okay? The explanation of all this is the two scenarios. In the two scenarios, you have either the sea, the water, or the road is the transmission medium, like the cable, the air, right? How what you use to transmit the signal is either the road or the water. The transportation protocol or the means here is either the trailer or the ferry. And lastly, the transported protocol is either the car or the boat here. And this scenario you can see, it is called encapsulation. So you are encapsulating a type of traffic in another type of traffic. Okay, so here for this technique, right, you encapsulate one protocol in another protocol, and you use this when your network doesn't support the encapsulated protocol. That is, the transmission network doesn't support the encapsulated protocol. You can use this also to provide a secure means. You remember we have the internet, which is a very large network, and then maybe this is your network A and your network B, okay? But you want to connect securely, all right? And then you still have like home users, okay? They want to connect to your network through the public IPv6, the public internet network, which is very, very insecure. So how are we going to do this? We can create a tunnel, all right, to transport our communication through. So tunneling can be used also for security. And the most common form of tunneling that we know is the VPNs, right? The VPNs, where we tunnel our traffic through a public network in a secure way. So the elements of a tunnel network is you have the transportation means, that's the transportation protocol, and you have the endpoints, right? The endpoints. And so we also have like the manual tunnels, which are the point-to-point tunneling. All right.
Okay, let me quickly answer. I see Mola, sorry if I pronounced that correctly. You say you missed slides 23, 24, 25, because I mentioned in the chat that it wasn't rushed. So it was only one slide, so 24, because 23 is not a slide actually. 25 is a title screen, but 24, let me just show you again, was where Stephen, if you can see it.
All right, so this slide is where I introduced the three categories of transition techniques. All right, I said there is the dual stack where you decide to put both IPv4 and IPv6 on your network. And when you're doing the stack, it means that all parts of your network, you're going to put IPv4 and IPv6. The tunneling is what I have been describing just now, where you carry either IPv4 in IPv6 or the reverse, that is IPv6 in IPv4. And then you have the translations where you actually translate a packet from one version to the other. That is when you receive IPv4, you can translate to IPv6 and vice versa. All right. So these are the three families of transition techniques.
All right, so I hope you can follow now. So what he did immediately after was now talk about tunneling, where we use the analogy of the ferry, which is a mode of transport, carrying cars, which are also modes of transport, but in a different medium, and he akin that to the medium being the cable, whether copper cable or fiber, or it's the air for radio waves or whatever. So the same thing here. And then we concluded saying, okay, this is the transported protocol, you can say modes of transport. The transport protocol itself, the one that can actually move on the medium. In the case, the trailer is the one that can move on the road, and the ferry is the one that can move in the water. And the transport medium is the water and the coal tar or the tarred road. All right. And then he went on to describe what is a tunnel. Okay. So one question on dual stack. So it says, can you please explain to me the dual stack? Does it mean that every device in the network have both IPv4 and IPv6?
Yeah, exactly. So because remember, IPv4 and IPv6 are incompatible. They cannot talk to each other. So let me just sketch a rough network. Let's say this is your network. You have this device. You have this other device. You have this device. And then all of them maybe are connecting to a switch where you have a server here. You have maybe a printer. And then you have some other, just think of anything. And then here you also want to access the internet. So let's say this is your network. Let's say this is your network. If this is your network, if you have if you enable if you enable dual stack in this network, it means that every device needs to support IPv4 and IPv6. Okay? Why? Let's say this device A wants to talk to server 1. If it sends IPv4 packet, right? The server must answer with IPv4. So you understand that the server must support IPv4. For some reason, if this device decides to send instead IPv6 packets, your server must also reply on IPv6. So here, when you say dual stack, it means that everything on your network supports both IPv4 and IPv6. If there is a device that's not supporting one of the protocol, it might not, you might have some service down. All right. Let's say for this server, for instance, this is your web server. I'm trying to get through on IPv6 and the IPv6 stack is not enabled. That is not going to happen. All right. So when you do IPv6, when you do dual stack, you have to do it for everything. Your security policies, your firewalls, your routers, your services, everything has to support IPv6 and IPv4 at the same time. That is dual stack. Now, there are some variants of dual stack that like the DS Lite, right? Dual stack Lite. All right. There are some variants where we try to, reduce the burden of having it enabled everywhere, because we know, not like enabling everywhere sometimes is a waste. All right. If you're already having like all your devices in the network supporting IPv6, why do you need dual stack? Why do you need dual stack? You don't need dual stack. But you might, since you are communicating with the external world, right? You might want to cater for the situations where when you query the internet over, let's say IPv6, that device on the internet is not supporting IPv6. You now need to fall back to IPv4. And this is not something that you need to come and sit on the device to do. No. Our operating systems already have mechanisms to, look at the internet and see, oh, if you've enabled IPv4 and IPv6 on my device, what is going to happen is that my device is going to first pick on IPv6. If IPv6 is not working, it's now going to fall back to IPv4. So yeah. All right. So
please put your questions in the Q&A, please. So Stephen explained, I hope you saw the different scenarios. So your question is about what is the best mechanism in all of the three. It depends. There are different scenarios. It showed you scenarios where your core was MPLS based, for example, no support for IPv6. Access, where your access network is the only one, mobile access network, or the rest of you are trying to access IPv6, a service that is only on IPv6. So there are different scenarios, okay? There's no one size fits all.
Yeah. And this is the reason why we kept developing these techniques, right? A lot of techniques. If you look at the works at the ITF, you will see that every day they keep like trying to improve the techniques, because at the beginning we think, oh, this is what is going to happen. And then we see, oh, there's this new scenario. We come up with a mechanism. So the best mechanism depends on your scenario, right? If you have a scenario where every device in your network can do IPv6 and IPv4, every device, every software supports IPv4 and IPv6, all your services can support IPv4 and IPv6, why don't you enable IPv6 and IPv4? Why don't you do dual stack? You might want to do IPv6 only, but the problem in that scenario is, if now you want to access the internet over IPv4, you'll have a problem. Maybe you can decide to say, okay, what I'm going to do is I'm going to do NAT64, where on my edge router, I'll configure it to be able to translate. When it is an IPv4 query, it will translate it. And when it's an IPv6 query, it will just go through. So it depends. It depends on the scenario you have to analyze. So if you have your network, you have the problematic, you look at it and then you decide which scenario fits best for your transition. So tunneling, we already explained this thoroughly, and as you can see here, we have two scenarios here, okay, where the endpoints in the first scenario, the two endpoints, the home agent and the remote agent, both support IPv6. All right. If they both, no, they don't support IPv6. They support the transition network. The transmission network supports only IPv6, IPv4, but the end sites are IPv6 and they want to communicate through IPv6 packets. What is going to happen here? We are going to encapsulate IPv6 packets in IPv4 packets. And then in a scenario where you have like the transition network, the transmission network only supports IPv6, but both end networks support only IPv4. In this case, you need to configure this in such a way that you encapsulate IPv4 in IPv6. All right. So to better understand this, let's explain manual tunneling further, and then we look at maybe the configuration later. So in this scenario, we have like three scenarios of manual tunneling, right? You have the router to router, all right? This actually connects two networks, two IPv6 networks, maybe across an IPv4 network only, all right? Say for Afrinic, imagine an Afrinic where we have offices in South Africa, in Morocco, in Tanzania, and in Mauritius. and we decide that for some reason we are going to run only IPv6 in all our networks in these various countries. How do we access our resources? Maybe someone sitting in Mauritius and he wants to communicate with a server in South Africa. What we need there is this is a scenario that we can enable tunneling. So we are going to have a router at the edge of our network here in Mauritius, another router at the edge of our network in South Africa, and then we are going to enable a point-to-point connection over V4. Then we activate tunneling, IPv6 tunneling in IPv4 on the IPv4 network. And the reverse is also true. In a scenario where you have only IPv6 in the transmission network, and then you can do the router-to-router tunnel. And then you have the host to router tunnel. All right. So as I decided that Afrinic network is going to be IPv6 only, but for Afrinic, we have also a work from home policy where people can work from home or people can work remotely. If you are sitting in your home network, most providers today support only IPv4. All right. So how do you access from your computer? How do you access the network? We are going to enable a tunnel, right, from your computer to the edge router of Afrinic. That is a host to router tunnel. And then now you have a host to host tunnel where you can link IPv6 host over IPv4 network, where various hosts can communicate to each other without seamlessly, right? All right. So in this scenario which we presented earlier, right, where you have the access network, and this is the case mostly that we have right now all over Africa and in some other parts of the world. IPv6, the access network is only IPv6. It's only IPv4. What are you going to do here? You can use tunneling here. I know you can use other mechanisms, but this is a scenario where tunneling works well. And also, yeah, it's the same scenario, but we just shifted the problem to the edge network. That is the network that leads you to the internet. Maybe your upstream provider does not support IPv6. What are you going to do here? Right? It's just some of these scenarios that I described earlier.
All right. Excuse me. Okay, so you can't change your name once you join the quiz. So that's why I said you need to be able to prove who you are by taking a screenshot of the emoji and your name and your username while you were playing the quiz competition, so that when we send you communication after this, you can let me know who you are exactly. I forgot to mention it. You should have entered the quiz with your first name and last name. All right, so let me start the quiz. So as usual, go to menti.com. Don't close that tab. 611529990 is the code, or you can scan the QR code on your screen. So how many are we here? We are 75, and there are 46 players in there already. Okay, that's a healthy number. I'm going to start it now. All right, so the question is, what type of address is used as a destination in an IPv6 over IPv4 tunnel implementation? Okay. I'll take go at this, Stephen. So, yeah, it's a bit confusing, isn't it? So what type of address is used as a destination in an IPv6 over IPv4 tunnel? So I reckon the tallest batch at this IPv6, you thought it's going to be an IPv6. But remember, it's been tunneled through IPv4. Okay? So that's why the first one, 11 of you who chose the answer, is correct. Do you shed more on that? No.
Yeah. So this is the two networks. Okay. And we are talking about an IPv6 over IPv4. It means that the transmission is what? Is IPv4, okay? But the network here is IPv6, IPv6. So here, this interface here, what does it support? It supports IPv4. This other interface here supports IPv4. So the destination, if I'm here, if I'm sitting here, my destination is here. Okay. If I'm sitting here, my tunnel destination is this. So the address of the tunnel is the IPv4 address of this interface. Most likely, not most likely, we recommend to use loopback addresses for the same reasons we explained the other day. Because, you know, if you use a physical interface, the day you change this interface, all right, you get a problem. The day you change the IP there, you get a problem. So preferably use a loopback address. So that's why this answer is the best.
Okay, so let us see the leaderboard with the usernames. So some people enter their real names, which is good. That will make it easy. So
Kati is overthrown.
Mhm.
Tom.
So Tom Ford is the one on top. All right. Thank you.
Okay, so how does these things work? The tunnel. All right. So here we have our network, the internet. The internet here largely is mostly IPv4 in Africa. Okay, it's mostly IPv4. And we have a customer, right? This device, I call it customer because in French, that's how we call the host device, le client. So I'm just doing translated
Translation,
French. Yeah. And so you have the client device here. It wants to access a service on the internet. The client here supports IPv6 only. Okay. So it's going to send the IPv6 packet. When the IPv6 packet hits the border router here, what's going to happen at the border router? The border router is going to encapsulate the IPv6 packet in the IPv4. So remember again the previous question. What is the destination of the tunnel? See, the packet is an IPv4 packet. So the IPv6 here becomes the payload of the packet. When it will travel throughout the internet, it will travel as an IPv4 packet until it gets to that destination. And on this destination, the router is going to de-encapsulate, remove the IPv6 packet and send to the server. So the server here it's very transparent when it comes to everything that is happening over here. It has no clue, no idea. It knows that it's speaking to an IPv6 device. Maybe it even thinks that the link throughout is IPv6 because it has no idea of everything that happened on the cloud here. So it's going to access the packet, treat it, and then send back a response, an IPv6 response. When it gets to this router, the router is going to re-encapsulate and send an IPv4 packet over the internet. And when it gets to the destination here, the destination is going to de-encapsulate and send to our client device here. And both the client and the server are not aware of anything that happens. All right? So this is how tunneling works. So what are the requirements for creating a tunnel? You need static addresses to represent the endpoints of the tunnel. So the endpoints of the tunnel here, like in the previous scenario, were those two routers. For those two routers, we needed an IPv4 address here, and here we also need an IPv4 address. That's the first requirement. If it is an IPv6 tunnel, we'll need these addresses will be IPv6. So the two routers can talk to each other, can communicate using IPv4. Secondly, so these first two, you need either an IPv6 a network or an IPv4 network. So as I explained in the previous slides, ideally, we recommend that you use a loopback interface so that when the interface falls, you can still continue, your tunnel can still be up. Normal network reachability, so the two devices needs to be able to communicate in the first place, right? Over IPv4. And then now you need the endpoints, the two endpoints need to agree on the configuration. And this is what we are going to look in the next slide, how to configure this.
Yeah, so but before we go forward, there are two questions here I see from Emmanuel. Emmanuel says, won't the packet lose its integrity when they when they are encapsulated in the process of tunneling?
So tunneling means you take the box, right, and you put in another box. Okay? How can I explain this? Let's say you go to, when you go to the post office to send a letter, all right? When you go to the post office to send a letter, maybe from Nigeria to Germany, what happens? You drop in your letter, and all of these letters are going to be encapsulated in a box. They are not tampering with your letter. They are sending your letter as it is, but they are putting it in a larger box where they can carry multiple letters. So encapsulation here means you take the packet as it is. You don't transform the packet. You put it, in this case, the IPv6 packet, you put the IPv6 packet as it is in an IPv6, in an IPv4 packet. You don't touch, you don't modify anything on that packet. All right. So this is your IPv6 packet that you are sending. And this is the IPv4 packet. This is the header, right? This is the header with source, destination, payload length, everything. And this is your IPv6 packet. Your IPv6 packet is going to travel safely. We are not modifying anything on the IPv6 packet. Remember the ferry carrying the car? The car is just sitting there on the ferry, and the ferry will lead it to the destination.
Okay. Ruan does raise some important observations or points there. Probably some of the shortcomings of manual tunneling. So it's asking, how does the V6 over V4 tunneling affect the packet overhead? That's like, for the case, it says, what if V6 only jumbo frames to the edge routers? Will it even work away from it? Are going to be too much? So that's one of the shortcomings of manual tunneling, which I think we'll see in the next slide, no, after the configuration. Because I remember we mentioned, was it live section 1 or 2? I can't remember where we say you don't, IPv6, you only fragment at the source. So, but V4 does fragment, you know, halfway during this. I mean, as long as the browser thinks, okay, this is not big enough. I mean, this is too big for my MTU size for my exit interface, it's going to fragment it. Emmanuel, are you sure you can hear me? You want me to come into the microphone? My voice is low. Is that the case for everyone?
All right. So as Olatunde was explaining, this is one of the problems that you can face with tunneling. All right. When you do tunneling, you have to make sure that the MTU, right, supports the size of the IPv6 packet. If not, because for IPv6, right, only the source and the destination do fragmentation, right? So if I want to send a packet, I am the one to do fragmentation. When it gets to the destination, it's going to be reconstituted. That's how IPv6 works. But in IPv4, we know that every router along the path will now do fragmentation. So let's say here you have an MTU, just pick funny numbers here, an MTU of 4 here. Here you have an MTU of 2. Here you have an MTU of 3. Here you have an MTU of 7. What is going to happen is computer A, when sending a packet, is going to fragment according to the 7. When it gets to this router, let's call it router A, router alpha. Router alpha is going to fragment it according to this 4. All right. When it gets here to router beta is going to fragment it to this 2. When it gets to router epsilon is not going to fragment because it has 2 already fits in 3, right? But in IPv6, you don't do this. Now, when you do tunneling, you have to disable fragmentation across, so that there is an algorithm called the path MTU discovery, right? This path MTU discovery is going to make sure that we know the MTU across the road to the destination, and then we do the fragmentation according to that size, so that this packet doesn't get fragmented towards there, so along the road. Yeah, also, you see, now we are carrying an IPv6 packet in IPv4. It means there is overhead there, right? There is overhead, so it's going to, you are adding the load to the network. But yeah, that's the price to pay for it.
So I believe your answer has been answered, believe. Okay, no pun intended.
So yeah, when we say IPv4 and IPv6 are incompatible, it means, what does it mean? It means that if I send an IPv4 packet to an IPv6 device, it can't read, it can't understand. Why? Because when you look at the structure of the packet, these two structures are different. In IPv4, you have fields like version, type of service, packet size. How do you call the packet size? TTL, source address. The source address is an IPv4 address. Destination address is an IPv4 address. In IPv6, on the other hand, you have fields like version, which is 6. You have a traffic class. You have flow label. You have payload length. you have hop limit, you have a next header.
Yeah.
In IPv4, you have protocol. In IPv6, in IPv4 is protocol. In IPv6, you have next header. All right, extension header. So you can see that only from the structure of the packet, there are two different things. So if you send an IPv6 packet to an IPv4 device to interpret, it can't interpret it. All right, it can't interpret it. Now, when we say you are carrying an IPv6 in an IPv4 packet, this is what it means. This is the beauty of the internet, is we don't care about what we are carrying, right? IPv4 can carry whatever type of payload you give it. You can give it music, it's going to carry it. You can give it audio, it's going to carry it. You can give it video, it's going to carry it. You can give it DNS traffic, it's going to carry it. It can carry whatever type of traffic you give it. It doesn't need to understand what is in that traffic. It is just there to carry from the source to the destination. Now, when it gets to the destination, look at this. This is router A. This is router B. This is host Z, and this is host X. All right. This is bad. How do I clean this? So you have this device here. This device does only IPv6. This other device does only IPv6. Now this network here is IPv4 only. So basically, this device X and device Z cannot talk to each other. You understand why? Because if device X sends an IPv6 packet here, right, it gets here, it cannot cross here, it's going to be dropped. So how will you make this happen? The way you make this happen is you make sure that on this interface of router A, you have IPv6. So that host X and router A can speak IPv6. You do the same here. You add an IPv6 here. So that host Z and router B can talk to each other. Good. This is the first step of solving this problem. Now, router A and router B can already talk to each other. When router A gets a packet, an IPv6 packet coming from host X, it's going to take that IPv6 packet. It doesn't care what is in that packet. It doesn't have to look through it. It just knows, oh, this is an IPv6 packet. So what I'm going to do, I have an IPv4 envelope. I'm going to put this in an IPv4 envelope and then send it across to router B. So that packet is an IPv4 packet, but it's containing inside the payload is an IPv6 packet. When it gets to router B is going to look at it and say, oh, this is an IPv. It knows that, oh, this is an encapsulated packet. So it's going to de-encapsulate it, remove the IPv6 packet that's in it, and then send it to host Z. I hope this is clearer.
Yes, and someone has added to that, which is good. One asks another question. IPv4 tunnel point to point with IPv6 data in the tunnel encapsulated, but you gents explain it perfectly. Oh, thank you. All right, sorry, thank you. Many Messia. Okay. All right, so yeah, we'll move on from there. It should be.
So this is the configuration. If you understood what I just explained, you will see that this configuration is very, very, very straightforward. This configuration is very straightforward. So look at the network. Look at this network, the same network that we shared previously. So you have router A here and router B. Remember, first thing we said that router A and router B needs to have an IPv4 address, ideally on the loopback interface. All right. So the loopback interfaces are already configured. Yeah, this is the loopback interface with IP address 192.0.2.1, and then the destination here loopback 0 again 198.51.100.1. So router A needs to be able to communicate to router B with these addresses. That's it. Now, on router A, I'm going to create a tunnel interface. Here we call it tunnel, right? You could call it something else, GRE, whatever. Tunnel 0 is the interface. This is a virtual interface. This interface is not a communication interface, it's a tunneling interface. So we don't need an IP there, IPv4. We put an IPv6 so that it's able to understand IPv6 communications. The tunnel source is what? Is this address? Is this loopback interface? That's the source. The tunnel destination is the loopback interface, sorry, of the other endpoint. And what type of tunnel is this? Is an IPv6 in IPv4 packet tunnel, right? Remember again that question about if we are having jumbo packets at the router, what is going to happen? So here we say tunnel path MTU discovery. This is how we disable fragmentation along. We are asking our router to make sure that it discovers the MTU along the destination and it does fragmentation according to that. And then now IPv6 route. This is very important. Every command here is very important. If you miss one of these commands, you are dead. Your tunnel is not going to come up. All right. So yeah, you need to create a route or your prefix, your IPv6 prefix. So every communication received from this pool, that's 2001 DB8 2000/64. All right, this is the address space that is sitting here. We needed to have specified that. So here you have 2001 DB8 2000:/64. This is the address range which is here. So we are saying for all communication that you want to send to this prefix, send it to tunnel 0. And when you send it to tunnel 0, that tunnel 0 knows how it's going to create the encapsulation. So this is how you configure it here, and it's good. You have to do the same configuration on the other endpoint. All right, on the other endpoint, tunnel 0 again, no IP address because we are going to use our loopback as source of the tunnel. This is the IPv6 address of that interface. The tunnel source is on loopback 0. The tunnel destination is that other loopback 0 on that on the router A. The tunnel type, we are doing IPv6 in IP, that's IPv6 in IPv4. And then we turn up the path MTU discovery so that you don't do fragmentation along the line to not tamper with the IPv6 packet. And then where that route, that route which you need to create for the prefix that's here. So there is a prefix here, 2001 GB8 1000 :/64. This is how you configure manual tunneling on a Cisco router. Yeah, this configuration is self-explanatory a lot for you to understand, and also to know how to configure on any other devices. So the requirements here is, first of all, you need an IPv4 address, okay, and preferably use a loopback. It has nothing to do with the technology. This is best practice. Secondly, an IPv6 address for that tunnel interface. You need to disable fragmentation along the path. Make sure that the fragmentation that is done at the source, it fits all the MTUs along the path. And then you need to enable the mode. You need to specify what is the destination address of the tunnel.
Okay, so I believe that answers your question, Ronald Edward, right? What's the difference between the tunnel modes, IPv6 and IPv6 IP? So it depends on what is transporting or what's been encapsulated.
Yeah. So IPv6 IP, it means IPv6 in IPv4. This is the syntax of Cisco.
Okay, so
requirements for
sorry.
Oh, we went back, Mr. Ola. So general problems with tunnels. This question is as if you were ahead of us, eh? Some of you are ahead of us. So fragmentation due to increased packet size, no problem for IPv4 because you can fragment IPv4 as you want. IPv6 doesn't permit non-source fragmentation. So routers within the path to the destination don't touch our IPv6 packet. Don't tamper with it. So we are going to make sure that at the source we run path MTU discovery protocol, and then we get the smallest MTU across the line. That's how we do the fragmentation. So manual tunnelings obviously are not scalable. So you need to look for a means to do that. But since but if it is an organization where you have like limited number of sites, this is something that you can easily handle manually. Yeah, possible suboptimal routing of IPv6 packets. All right. So next is a quiz.
Excuse me. So please join mentee.com. Join the quiz, sorry. The code is 61152990. If you're just joining now anyway, but if you join at the beginning, you'll still be with us here. Oops. Sorry.
If somebody is just joining now, it means that they can't win this race.
Yeah, but they can get knowledge.
Yeah.
So I'm going to start the Mentee. There's 78 of us in here, 48 players in there right now. Looking at 55 before I push the start quiz. Okay, so I think it's good to start now. Can you see the image? Let me try that. Okay. I can't display the image here though, but it's a Wireshark capture of a tunnel packet. Okay. The answer is actually IPv4.
Right. Technology.
I wanted to explain to you how, but I need the image. I don't know, because I joined late, so I can't see it on my phone. I wanted to be sure you saw it on your phone. Did you see it? It was too small on your side, right? I was not visible enough. Ooh la la. All right, so I mean, we'll do some magic concerning that, computing the scores. But if you didn't guess the answer, very good.
Cathy is back. Oh, Cathy is back. Cathy is back at the top.
All right. All right, let's move to the last section of the presentation. Let's see, that would be.
So we want to talk about NAT 6.4. And I guess all of us here, we are very, very familiar to NAT. So it's going to be very easy to understand.
Okay. So, but before we start, this time around, there's no image. Sorry. Squeeze. I'm very certain there's no image. I'm sure we're all in here. Oops, sorry again. Technology. Yeah. Let me start the quiz here. All right, so let's hit 50 and then I start the quiz. Got 6 players in here. Quiz it. 47, 48, 49, 50. All right, I start the quiz. What is the primary function of NAT64 in an IPv6 network? Let's say choose the best option. All right. Short time to choose. All right, so yeah, that's why I say you should choose the best option. Now, the first one, yeah, technically correct, but it's not the best. Okay, so this scenario is most likely unlikely because usually you have services now being dual stacked, right? So V4 and V6. But in the case of IPv6 only services, yeah, that's why the second choice is to convert IPv6 packets to IPv4. All right, it is the best choice. Number one is not wrong technically, but converting IPv6 packets to IPv4 packets is the best out of the two. So, but number two, the option for subnet is definitely not. It's out of the question. And then to manage the IP address allocation for IPv6 networks also is out of the question. All right.
Okay.
Let's see the board.
Kelvin.
Kathy is still first.
Cathy.
So I think I'm not sure if there's one more quiz. So if you know yourself, just save that we know who you are when we are computing. All right.
I was trying to draw a hand
Yeah.
to clap for Cathy.
That is a terrible attempt, but good.
Oh, okay. So, NAT 64. Okay. Let me not spoil the movie and just present these things the way they are. So, the components of a NAT 64 environment, you have an IPv6 only client trying to get on an IPv4 only device. So you see, the previous scenarios is we're having IPv6 client to IPv6 server. Now, what if we have an IPv4 only server and we want to reach that server using IPv6 only device? All right. So in the scenario of NAT64, we need a DNS64 resolver, and then we need a NAT64 translator. Now, let's present each of these components, how it works, how it serves in the topology. So the NAT64 translator is a dual stack device, right? And it has an IPv4, right, interface that can reach the IPv4 server. And it has an IPv6 interface that can reach the IPv6 client. And then it has the capability of translating an IPv4 packet into an IPv6 packet and vice versa, so that these two devices can talk to each other. That's the NAT64 translator. The DNS64 is an extension of the normal DNS. So you have a normal DNS that you've configured, you're buying, and then you've done all the configurations of entering the records, A records, quad A records, and so on. And it has there is a well-known prefix. There is a well-known prefix for this technology, the NAT64. It's 64FF. Yeah, 64FF/96. And then now you can input your it will use this prefix to fake IPv6 addresses. So let's look at the graphical representation of this thing. Yeah. So remember the problematic here, the problem we are having at hand here is that we have this device. It's an IPv6 only device, and it's having this IPv6 address 201.1db8::2. It wants to reach to this server, and this server is an IPv4 only. That's www.example.com. It's having only an IPv4 address. That's 192.0.2.6. So we already explained that this host, if it sends an IPv6 packet directly to the server is not going to understand that packet. So this technology of NAT64, how does it operate? Remember, the components that we have that we bring into play is the DNS64 box and the NAT64 box. So the host, the IPv6 host, has the address of the server, www.example.com. So first thing, is going to send a query, a DNS query to the server, a quad A query for that matter, asking the server, what's the IPv6 address of example.com? When the server receives this, since you have enabled DNS64, it's gonna say, oh, it's gonna send this query to the internet. But now, sending the query to the internet, asking for the IPv4 address of this host. And then the response from an authoritative DNS server that has authority over the domain example.com, it's going to come back with the IPv4 address 192.0.2.6 of this server. Now, the DNS server is a liar. It knows that, oh, this host doesn't support IPv4. So I'm going to create some fake IPv6 address. The well-known prefix that I named previously, 64 FF9B:96/96, is going to create an IPv6, a fake IPv6 address. So what it's going to do is, it's going to translate this decimal representation in an hexadecimal format. So if you take 192.0.2.6, you convert into hexadecimal, it's going to give this. So it's creating this fake IP address, IPv6 address, and it sends it to the host. So the host is now going to create a packet, an IPv6 packet. Source address is going to be the address of this host, which is here. Destination address is going to be that address that it got from the DNS server. When this packet gets to the NAT router, the NAT router is going to look at it and say, oh, this is the well-known NAT64 prefix. So I know that this is not a real IPv6 address. What it's going to do is going to look at this last portion of the IP address, right? And it's going to configure to translate it back into IPv into dotted decimal. Is going to give it 192.1.0.2.6. Then the packet is going to now do the normal NAT stuff that we know. What is NAT? NAT 44 is you change the source address and the destination address. So it's going to change the source address. It's going to create a packet now, an IPv4 packet with the source address being its address here. All right. And the destination address is the destination address of the server. When it gets to the server has no clue of this customer, of this client. It's going to communicate directly with the NAT64 box when it creates the response. So the response is going to go destination address, the address of the NAT box, and then source address, the address of the IPv6 host. When it gets back to the NAT64 box, the NAT64 box is going to go and look at the NAT table, all right, at its NAT table to see who is the normal recipient of this IP packet. Then it's going to create it back, put the source being that IP address that we know, that fake IP address, and the destination of this device. That's how you enable communication between an IPv4, an IPv6 only host with an IPv4 only router device. Now, this is NAT64 and DNS64. If you look, there have been many other enhancements. You see technology like 464 XLAT and things like that, which are improvement of the NAT64.
Okay. So yeah, that's actually the end. But like I've been saying since the beginning of this week about you completing those courses, the Mastering IPv6 Transition Mechanisms course comprises all of this. So you have the normal dual stack Lite, the tournament mechanisms, the DNS64, NAT64, which includes map E, map
D,
map T, sorry, yeah, so translation, and E is for encapsulation, and then 464 XLAT, like you mentioned, for you mobile guys. So you get more details in that, and even some of the configurations for this on CPEs. So I encourage you to, if you want more, to complete those courses. Okay, they have more. Just like I said with the routing, also has more to offer than, because if you want to cover everything in this session, we see we've gone over almost 2 hours already. It's going to be way, way, way too long. All right. So with that said, I don't see any open questions. I don't see any open questions here. So I'm guessing we are good because we did answer some of the questions. Most of them as we were going. Some of them were answered before you asked, I suppose.
So just ask your questions if you have any. Yeah, we are here for you before we now go to
the survey, and then we spin the wheel. So any questions while I kind of set up here?
Why are you silent? Does it mean that?
So someone said the top 5 get 100% discount provided you complete all those 7 courses and you pass the final quiz on or before 25th October 2024. And on that day, I have scheduled the closing event. Thank you for that comment, Gofran. We appreciate it. Hey, Ron, don't leave yet. Yeah, we also want to go for the weekend, but hold on. And then you've been in top 5. So all right, let's go for the survey then, if you don't mind, since we don't have much questions. Yes, the spin the wheel winners also get 100%. But like I said, it's all tied to you finishing on or before 25th October. And so we saw what happened with the sources and destination address fields of the IPv6 and IPv4 headers. What about other fields? When it's, well, it's encapsulated, remember, so it is transparent. So if you have VIV6 being tunneled through V4, what you see is IPv4 fields, okay? That is, it's at the destination that when it's stripped apart, then those fields for the IPv6 become, relevant. All right, so I hope I got, oh, no. Okay, well, I think it's correct. Let's see, 1 second. Okay, I'm going to cheat. 1 second. You see the 4? You know how I know when something is wrong? See bit.ly / is ls live session. What it's saying now is live session 4th October. That's 0410. But we are live session 5 actually. So that 4 is supposed to be a 5. But I'll change it. You can change it yourself, but I'm going to change it. Or let me just paste it in the, sorry. Let me just paste it in the chat. Sorry about that again. So I invite you to take the survey. You can scan the QR code. I think that one is working. All right, so I'm going to paste that in the chat, the link in the chat. Yes. Sorry, Gofran, I made that mistake again. Huh. Is that correct? Let me click on that. Does it work from there? Yeah, so just copy the link in the chat, please. Then when we get a healthy number, we have 65 participants. When we get a healthy number, we'll just we'll spin the wheel. And we'll get our 2 lucky winners for another 100% discount. have 23 full completions. It's very short. That's 30 seconds, you're done. I have 36 completions, 65 here. This I'm trying to hit at least 50. So we have 14 to go. Okay, we have 13 to go now. One. Okay. So 4 more people here. Or if you have it partially complete, if you can please complete it, and then
Please complete this survey. This is how we try to improve on the material, the delivery, the processes.
right. Two. Stop sharing first of all. 1 sec. For the wheel of names, you need audio. I can't. All right. Fortunately, you will not have the sound for the spin the wheel. I was trying to share the audio, but you know, live demos usually show their ugly heads once in a while. So all right. So okay, perfect. We have just people left. So let me drag the wheel of names over here. Where is it? Yeah. So you're all there over here. And then I'm going to spin it twice. All right. So let's do this. So when your name comes up, please you just raise your hand and then we know you're here. Then I can. Otherwise, we'll wait and then I'll remove you and then we spin again for someone else to win. Give the opportunity for someone else to win. All right. So let me spin in 3, 2, 1.
Can you hear the sound?
No, I can't hear the sound. Clever. I've been seeing you. Yeah? I'm not sure. Have you?
Clever, are you in the room?
Yes, Clever is here.
Oh, Clever. Congratulations, Clever. You're a clever person.
All right, so remove you. And then second lucky winner.
Razan. Razan Altai.
Razan, have you won before?
Yes. Razan won the last week, right? People can be lucky.
You can't win twice. One sec. Mm,
Is Razan here?
second, let's check. Those who have- Okay, so Razan has never been a winner.
Okay. Is Razan among us? Please let us know.
She's here. Where? I don't see her. Raise a hand.
Razan, we need to see you in the chat or raise a hand. Luis is like, give it to me. Razan 1.
I need to see confirmation.
Razan 2.
You have bad internet. Yeah, but can she type in the? Do you maybe just raise your hand or type in the chat? Just getting in and out. Is she in the same office with you, Gofran or something? I don't know. So let's be sure. I need some visual confirmation, please.
Razan is in the class, but you must show up. You can't have just type. If you don't type, you will not be able to confirm. Razan 1, Razan 2, Razan 3 gone. Let's move it to something else.
All right, so spin it. All right, this is a new name. Zulu, eh?
Zulu, are you here? Please let us know.
Kobe. Are you here?
Zulu, are you here? Zulu is in the class. We need to hear from you. Zulu, 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 Zulu.
Yes, Gofran and Rosanna, I'm sorry. We needed some confirmation to know if she was really here. Zulu hasn't confirmed either?
No.
All right, so
Zulu 1, Zulu 2, 3, and gone.
right, so okay, Wilfried Batako.
Agigetina. She's
Wilfried.
not here.
Okay. Yeah, guys are blowing it there. $100. All right, let's spin it again. This is the very last person we want to select as the lucky winner. This is the last live session. Michael is new. Yeah, I don't see your name in the list. Michael, are you here?
Yeah, Michael is here. Thank you.
Awesome. All right. So
Congratulations, Michael.
Okay. My mouse. All right, so we've done the survey. Just found the wheel. And yes, before I say thank you again, please note that all of this, 100 USD, like you said, for all who have been selected since the first live session, either by top 5 during the quiz or by the 2 lucky winners with a spin the wheel. Please, it's for you to benefit this. I'm saying it again. I know I sound like a broken record. You need to complete those 7 courses on or before October 25th, Friday, October 25th, and pass all the exams, all the tests or quizzes at the end. Like I said, you can take the exams or the quizzes, as much as you like for you to pass. It's not like you have limited attempts. You have unlimited attempts. Okay. So this is the last live session. The next time you see us is on that day, Friday, 25th of October. If it's going to change, we're going to communicate that to you. But it's that day we have the closing session where we announce all the winners again. Okay. But in the meantime, because now the website or the platform is up, you can post comments in the discussions. I'm looking through that. I'm monitoring that. My other colleagues are also monitoring that. If you have any questions, you can post them in the relevant discussion threads, or you can send an email to training@acronic.net. Like the email you've been getting emails from, right? And we will respond as soon as we can, as fast as possible. So I saw a suggestion earlier today about why not send one email that has all the links to all the live sessions and the PDF versions of the slides. So what I'm going to do, so most likely you get that email on Monday, not today, is that this final email, you're going to get a link to all the live sessions. It's a playlist on our YouTube channel anyway. And you're going to get a link to all the slides in PDF format to download. So you have one single email that has everything. Because I think some of you have been getting lost checking through which email or what email did I get it or did I get it? Because someone says today that they didn't get the email for yesterday, for example, which I believe was sent to all of you. Usually some of you maybe you register with your work email, but the email we have is your work email. And you're checking your personal, the one you use, your personal email account. I don't know. So, but anyway, latest by Monday, because I don't want to send you emails on the weekend. I want you to be having fun. But on Monday, so that when everybody is back to work, you get the email that has all links to the recordings of the live sessions and the PDF versions of all the slides. Okay? So with that said, I would like to thank you all for, this was the sixth edition, like I said, and it presented very interesting challenges. We've always been having challenges anyway since the first run, but this was a very interesting one. And you stood by us through it all. And I really, really appreciate you for that. All right? Or we really appreciate you for that. So with that said, thank you all again. And I will hope to see you in the different discussion threads on the platform. And then hopefully we'll see you all on October 25th for the closing event. All right? Thank you very much. You take care and have a lovely weekend. Bye.
Bye-bye.